Hi guys, it's Miss Davis again, and we are finishing 5.2 today. So, 5.2, we are now on page 195, and yesterday we talked about congruent polygons. Today we are going to talk about similar polygons. So to start off, we need to discuss what similar means. So similar, unlike congruent, means that it can be the same shape but different sizes. So a lot of times when you're dealing with shapes, you have things that end up being similar but are not necessarily congruent. So that's what we're going to talk about today. A couple things you need to know about this is that all corresponding angles must be equal and that all corresponding sides must be proportional. Now, I know since none of y'all were in the class with me at the beginning when we did proportions, this may actually end up being a review on proportions as well. But proportions are something that you will be using, so it's a good review to be doing. Okay? The ratio of similitude is how you tell if they're proportional. So when you're dealing with triangles, you actually have something that you can say similar by AA, and that is if they have any two angles that are congruent. If they're two corresponding angles, and that means that the triangles are similar if the angles are equal. And that has to do with the fact that triangles only have three angles, and all three angles of a triangle add up to equal 180 degrees. So you could prove them similar by AAA if you keep going. So they just stop at AA and say, we're going to save you some work, they're similar. So when you do that, you can come up with something known as the ratio of similitude. Now, this ratio is what is used to prove polygons of more than three sides to be similar. And you're going to have to use this because you can't just say AA for a square or anything like that. And I'll show you why in a little bit. Okay. So here we have two different triangles, and the ratio of similitude is set up between corresponding sides. So I'm going to put it up here. I couldn't get it to come up separate. So if you can see, we put the red sides over each other, the green sides over each other, and the blue sides over each other. Now, the way I set my triangle up, I put the big one first and the little one second. Your book has it where the little one is first and the big one is second, in which case their ratio of similitude would be separate. You just put the first triangle over the second triangle, even if it's the larger over the smaller, or the smaller over the larger. Or you pay attention to what they're asking. So we have example C. So we're going to look at this triangle and we're going to see, are they similar? And actually we can say, yes, they are similar by AA, which is what I mentioned on the last slide. So we need to come up with the ratio of similitude. So in this case, we've got the larger triangle on the left, which is assumed to be the first position, and the smaller triangle on the right. So we're going to simply write this as 5/3. Okay? Now let's look at these two rectangles. Are they similar? Well, they're both rectangles, and we know rectangles have all four angles that are equal to each other because they're all 90 degrees. So we have to check the ratio to see if they are similar, because remember, AA only works with triangles. So we have to check the ratio for these. So let's see. We've got 3/5 not equaling 7/10. And the reason for that is if you actually get least common denominators and you end up with 10 for both of them, you can see that 6/10 is not equal to 7/10. So these are actually not similar. That should be a big flashing light right there that says not similar, but I did not put that in the slideshow, so you just get it telling me, that. So they're not equal. Okay? So, that should not be there, so we're just going to move forward and ignore that. Because of the ratio of similitude, we can actually solve real-life equations for these types of problems, and they have been used before, especially when dealing with shadows and sunlight outside. The ratio of similitude will always be the same between all sides of similar shapes. As long as we know the shapes are similar, we can solve for any missing side. And this is true. It's most commonly used in triangles, especially with example D here. So we have Matt knows that an object and their shadow form similar triangles because of the angle of the sun. If Matt, who is 5 feet tall, casts a shadow that is 4 feet long, how tall is a flagpole that casts a 20-foot long shadow? So I have a picture for you here. I couldn't get all the fancy little pictures that your book has, so I'm sorry, but the 5-foot side is Matt, and then the vertical side that's not labeled of the larger triangle is the flagpole that he's trying to measure. So we need to set this up as a proportion. So the first thing I'm going to do is I like to set up what we know. So we know that 4 feet over 20. We know that one first. And so we're going to do 4/20. We're going to do smaller over larger. And then we have 5 feet over the unknown value because it's his height to the flagpole's height. Okay? So from here we are going to cross multiply to solve this proportion. So I'm going to do 4 times x equals 5 times 20. Okay, I'm going to multiply that out, and I have 4 times x equals 5 times 20 is 100. Then I have to fraction both sides, divide both sides by 4, and I end up with x equals 100 divided by 4, which gives me x equals 25, because we know there are 25 cents in a dollar, 25 cents in a dollar. And that gives us our answer as 25 feet. So, our answer is 25 feet. That is how long or how tall the flagpole is. These types of problems are going to show up a lot in the future and in any future math classes just in general. They are known for being some of the easier ones to solve because a lot of times it's just setting up a proportion, cross-multiplying, and then solving that equation, which is what we've been spending a lot of time doing. So I have confidence that you guys can figure this out. So your assignment is in the email. Make sure you check it. Make sure you do it. Shoot me an email if you have any questions. Don't forget, I am here if you need anything. So I will see you guys in tomorrow's video.